Hi everyone, in this video I'm going to explain the things which I have learned and which I have implemented for my Python deep learning lesson 6. So in this basically we have learned how to build an autoencoder and how to encode an image and how to decode an image by using autoencoder, and also we have used two types of autoencoders, that is, one is noisy and other is simple and stacked encoder. So coming to the programming part, I have been given with an starter code, so I need to add one more hidden layer to that autoencoder. So if you can see, this is the code for autoencoder. So I have used input dimensions as 32, so I have taken the input image in the shape of 784 comma, and I have added two layer, a single layer to encoder and another layer to decoder. So if you can see, this encoded layer will be the input for this encoded part. So I have given the input here, and for the decoding part also we need to add one more layer, as both the encoding and decoding should be symmetrical. So for the first decoded, we'll be taking the second encoded as the input, and output image will be taken this decoded as input. And I have created a model which is taking input image and output image, and I have named it as autoencoder. So after that I have to train my data and I have to test my data, but here it's an unsupervised data, so we don't have any outputs. So what we have done is we have taken two as training data sets, and we have done the validation test on X test and X test. We don't have any Y test. Even when we run this model, we won't be getting accuracy. So I have added accuracy by using this metrics function. So I have run this function, and this is for the first part. I need to add a single layer, and coming to the second part, I need to display that image before reconstruction of the image and after decoding, the image before encoding and the image after encoding. And even for the bonus point also, we need to display the data after encoding. After encoding, what should be the output of the image. So for that I have already ran the code. So if you can see, this is the image to be encoded. This image has to be this image is the first image. This has to be encoded, and this is the image decoded. After all the reconstruction has been done, this is the decoded image, and this is the image after encoding. After encoding, this is the image, and even I have plotted the graph for the accuracy and the loss. So if you can see, this is the model accuracy, this is for the training accuracy, and this is for the test accuracy, and this is for the losses. And coming to the third part, repeat the question 2 on denoising autoencoder. So I have used the same code which I have done for the second part, and we have added a noisy part into this. So if you can see, this is the noisy part which I have included. So and even we have changed some things in the history parameter. We have used for validating data, we have used xtest noisy and xtest noisy. Previously we have used just the xtest, and here also the same thing, and we have plotted the graph for the image encoded and decoded. So if you can see, this is the image which has to be encoded, and this is the part where this is the decoded image.